Assalamu alaikum. We know uncertainty in the measurement is referred as error. It can also be defined as the difference between actual value and the measured value. You might have heard the proverb, to err is human. It means it is a nature of a human being to commit a mistake. So whenever we perform an experiment, the measurement of quality in the experiment results in some sort of error. These errors are mentioned or classified as gross error, random error, and systematic error. In this video, we discuss gross error and random error. So let me start with the gross error. What is this gross error? What is the source of this error in the measurement? Gross errors are mainly due to the sheer carelessness of the observer who performs the experiment. Errors that occur only due to the sheer carelessness of the observer is referred as gross error. Now, there are many reasons for gross errors. What are they? Let me mention them one by one. Suppose a person is performing an experiment without bothering about the source of error. Then some error may occur. That includes in gross error. Performing an experiment without bothering about the sources of error. The second, if the instrument is not set properly, no, it may also cause some error. That come under a gross error. Performing experiment without setting the instrument. Performing experiment without setting the instrument properly. Okay. Now third, sometimes what we do when we perform certain experiments, suppose I use a spectrometer. Now before using a spectrometer, some initial adjustment has to be done. If we start the experiment without doing so, then it results in some error. Like I can also give the example of a tangent galvanometer. When we start the experiment with a tangent galvanometer, before doing so, it has to be set properly. Now, the compass should be completely plane with the surface on which it is placed. So for that we use a split level, and the aluminum pointer must read 0, 0, and it is by nature that the magnetic needle which is present in the compass always towards the north and south pole. So it should be set in such a way that the aluminum pointer which is present in the compass must read a 0 and 0 0. Without doing so, if we just start the experiment, then it may result in some error. Okay, so starting an experiment, without initial adjustments. It's also a reason for the occurrence of a gross error. And our next thing, recording a wrong value in the observation. Recording a wrong value in the observation. Now, for example, if the correct reading is 12.9, instead of that, the person by mistake recorded it as 2.9, then it will result in some error. Okay, this is what it means. And next, very common mistake done by most of the people while performing the experiment is using a wrong observation value. In the calculation. What does it mean? Now suppose we perform an experiment in which you need to mention the value of acceleration due to gravity. Suppose you need to write the value of g. We know the value of g on the surface of Earth is nothing but 9.8 meter per square second. Now if you are not aware of this value and by mistake instead of 9.8 meter per square second, if you have mentioned the value in a different way, suppose instead of 9.8 meter per square second, if you just mention 9.3 meter per square second, for example, then this may result in some error. That also includes in a gross error. So how one can avoid a gross error? Gross error can be avoided only if the person who performs the experiment is highly precautious. Now, if the person is highly careful, only then this kind of error can be avoided while performing any experiment. Now let's discuss about a random error. Random error. What is this random error and what causes it? Now you might have observed when we measure a quantity, all the times we perform the experiment, the value obtained changes. Suppose someone is trying to find the thickness of a wire with the help of a screw gauge. In such case, the first time when he performed the experiment, he obtained some value. Let it be 0.3 millimeter. Next time when he perform, it won't be same. It will be around 0.31 millimeter. And third time when he performs, it may vary. Now suppose I say that the person is performed the experiment to measure the value of A. The first time he performed the experiment, he get the value of A to be equal to A1. The second time, the value obtained is slightly different as A2. Third time, when he performed the experiment, it is found to be A3. Like that, when he performed the experiment nth time, the value obtained is AN. So here, all the time the experiment is performed, the value obtained is different from each other. This is due to a random error. Here, the error that occur do not follow as a pattern. So this kind of errors which occur randomly is referred as random error. Okay. How one can avoid this kind of error? This kind of errors can be avoided by taking the arithmetic mean of all the values that we have measured. So the mean that we get at the end is referred as the most possible true value. Okay. Now how it can be done? Let me show you. Now suppose to take the arithmetic mean, all these values are added up. A1 is added with A2, A2 is added with A3, like that. We go for all the values up to AN. After adding them all, the sum of the value is divided by the total number. Here we have performed the experiment n number of times. See, the total number is n. So the sum is divided by n. At the end, what do we get is nothing but the arithmetic mean, or sometimes it is also referred as average value. Okay, this arithmetic mean obtained is taken as AM. Here M stands for mean or arithmetic mean, and it gives the true value. Okay, the possible true value. Now in mathematics, also in physics, the addition, for addition we use a letter called a sigma. Sigma is used. This denotes the addition of certain quantities. Okay, here A1, A2, A3 up to AN are added up. So to show this addition, I use a sigma. Okay, so here in the place of all this value, I take AI. Okay, and here I value is found to be equal to 1 to n. Okay, let's see, have value from 1 and it's at n. This is what I mentioned here. Clear? And in the denominator we have n, so it has to be mentioned. So write it beside. Right? So this is the method of representing the true value. Okay, I write this here clearly. AM is equal to 1 upon n summation of AI, where I equals to 1 to n. Okay, this is the method of taking the average value of a large number of measurement we obtain while performing an experiment. Okay, so this way the average value that we obtain now is referred as the true value. By doing so, the random error can be avoided to some extent. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your questions in the comment section. Thanks for watching.